The fundamental types can be categorized according to what they hold, what kind of information they hold. So there are a series of types, for example, that hold integers, numbers without a fractional part, like 3 or 702. And in C++, we have short, long, int, unsigned short, unsigned long, and unsigned int. Short and long are, as you can probably guess from their names, different lengths. They have a different number of bits in them. And int is a convenient type that is actually chosen a length to be the most efficient on the machine where it's running. So if you really don't care about the length at all because you're just going to put a number in it like 3, int is a great choice. The unsigned versions can each hold a number twice as large as the signed versions because they don't use a bit for sign. We'll talk more about how many bits a number can hold and what happens if you try to put over large numbers in a little while. You won't go wrong when you first start by just putting integers into variables of type int. It's easy to remember, it's probably right, and unless you happen to be getting near the limit of the number that can fit into the bits, you're going to be doing just fine. And that's a very large number, as you'll see shortly. Now, if your number has a fractional part, if it's 7.2, 3.29, then that's a real number, and you can use either float or a double. And double has more capacity, can hold larger numbers and more digits of precision than float can. Most of the time, just put things in doubles and your life will tick along as you expect. There's also a type called character, and believe it or not, C++ people argue about how to say the name of this type. Some people, including me, pronounce it car, but you will meet people who call it char. Take my advice and don't argue about how to pronounce variable types. If someone says char, this is what they mean. If someone says car, this is what they mean. You pronounce it however you want. There's even an unsigned car, which probably doesn't sound like it makes any sense. I mean, what's minus a? Or, for that matter, how is plus y different from minus y? Well, because car is a very small number of bits, only 8 bits, people sometimes use it to hold little numbers, like 3. And they therefore want to be able to distinguish whether they're putting, say, minus 3 in it or a positive number. So car and unsigned car can technically be used for numbers. They can also be used to hold a single letter. And finally, we can round out our fundamental types with Boolean values, true or false, and they are of type bool. The only values you can put into a bool are true or false, but there are ways to convert to that from other values, and one thing you'll especially see when we get into operators is people converting back and forth from numbers to Boolean. But the only values a bool can hold are true or false. I have a demo to show you that will sort of take these types out for a spin. Show us putting some values back and forth into different types of variables and what happens, especially when you mix and match types and convert maybe from one type to another. So here in Visual C++ Express, I have a project called Variables and Types. You see, for example, here we declare an integer called I1 and initialize it with the value of 1. And then I'm printing the values out onto the console output. And that's why I have this include here of IO stream so that I can use standard console output to write to. I declare another integer here and don't give it a value right away, but then give it a value on the next line. And there's really no important difference between these two for integers. There can be a difference for your own user-defined types. I'll talk about that in a little while. And then this third way, which some people ask about when the first time they see it, actually initializing that integer using these round brackets. And this is another way to do it. It's simply a matter of taste. These three have no real difference. If I run this application with Control F5, let it compile, and then I'll just pull this window down so that you can see the code. Hopefully no one is terribly surprised that I1 comes out as 1, I2 as 2, and I3 as 3, because those are the values that I've initialized them to. We scroll down a little further in the code, you can see we've got a couple of doubles here. I'm putting a real number into D1, 2.2, and for D2 I'm assigning it to the value that's in I1. So I1's an integer, and the integer is, we say, promoted to a double, and there's no loss of any information. That's just fine. But this next line, we take another integer I4 and we assign it to this value that's in D1, which is 2.2. Now you can't put 2.2 into an integer, so we're going to lose some information. If you're expecting a runtime error from doing this, you don't get one. Let's take a look at the output. Obviously there's no error messages. D1 comes out as 2.2. D2 comes out as 1, which is what was in I1. And I4 comes out as 2. The value is just truncated silently at runtime with no complaints. And if that was what you wanted, fantastic. If it wasn't, there was a way to find out that you were going to have this problem, but it's not something you'll be told about at runtime. Let's carry down here. I have a character called C1, and you can see that it's perfectly ordinary to put a value into a character using single quotes, then the letter, and end single quote. I have a line here that's currently commented out that uses double quotes. I'm going to let you see the error message from that in a moment. We print out C1. Not surprisingly, it's A. Then I have some Boolean values. I call it flag, and I start it as false. Print that out. It actually prints out 0 when you send the Boolean value to cout. Then I take that Boolean value and I assign it to I1, which you remember had the numerical value of 1. And sure enough, it comes out as 1. Sounds like you can put a number into a bool, so just to prove you can, I'm going to take this double number, D1, which has the value 2.2, put it into the flag, and it still prints out 1. Because really what flag is true. And when you send true to console output, it happens to put a 1 on the screen, but its value is either true or false. And the easiest way to see that is if I rerun the application under the debugger. So I'm going to stop this run. And just before I do the debugger run, I'll show you what would happen if I were to try to compile this line that's trying to initialize a character using double quotes rather than single quotes. To a lot of people from other programming languages, when they see double quote B and double quote, they think, well, that's a single character. But it's not. It's what a lot of people call a C-style string. It's actually an array of characters with a special termination character at the end of the array. So one real character, the letter B, and the special termination character. We're not using those kinds of strings because I think the standard strings are much easier to work with. But I just want you to know that you can't initialize a character using a string. So you can see there's red wigglies here. It says error, a value of type const car star cannot be used to initialize an entity of type car. The important part of that is probably the word error. When you want to initialize a character, use only a single quote. Single quote for a single character. Easy way to remember it. So let's comment that back out. And this time I'm going to run the application under the debugger because I want to show you how the debugger displays Boolean values. Now, the exact ins and outs of how to debug an application are not what we're here for. So I'm just going to kind of treat the debugger as a way to let you see values. The way to see values is to pause the program, and you pause at what's called a breakpoint. Lots of ways to get breakpoints in your application. If you're not familiar with Visual Studio, probably your best choice is to simply right-click on a line, breakpoint, insert breakpoint. Once you're a little bit more familiar, you'll recognize this gray margin as sort of the breakpoint margin, and you can click on one to make it go away or click on the empty margin to set one. But if you're not 100% sure which margins are which, right-click to set your breakpoints. Now when I hit this, we will run just up until the breakpoint, and then we'll stop. Now here, stopped at the breakpoint, you can see this window here called Autos. If for some reason you don't see this window when you're doing this yourself, you can go on the Debug menu, choose Windows, and bring up a particular window that you might want. Locals is a perfectly good substitute for Autos. It simply shows a few more values. Now you can see here that paused execution before we're running this line, the I1 value is just gibberish. In fact, what the debugger is showing is just what happened to used to be in that memory. We haven't yet declared the variable or put a value into it. So if I step over this line using the step over button on the toolbar, now you can see down here that I1 has the value 1. Now, none of this is terribly exciting because you watched all these in the console window and they probably weren't that exciting the first time through. So I'm just going to scroll down to here, right-click, and choose Run to Cursor, just to whiz past all of that. Because what I actually think is worth seeing is the way the debugger displays our Boolean value of flag. So when I step over this line, let's look around and find flag, it has the value false, and you see that the debugger doesn't show 0 the way the console output did, but actually shows false, which is much more helpful for you to understand what's going on. Then when we set flag equal to I1, which has a numerical value of 1, now the debugger reports that as true. And when we set flag equal to D1, which has a numerical value of 2.2, you can see that the debugger continues to report that as true. So using the debugger can sometimes give you a little more insight into what's going on and how your data is being interpreted. The console out writing isn't always quite as useful as the debugger. To kind of illustrate that a little more firmly, I'm going to uncomment some code that I've had hidden. And this is some code working with characters but putting numbers into that character type. The reason I'm doing this with character is because it's small enough that we all kind of know what it can hold. An unsigned character holds 8 bits, a signed character holds 7 bits of number. And 7 bits is a number up to 127, and 8 bits is a number up to 255. Now, just before I uncomment this code, I want you to see that it uses the other style of C++ comments. So you've already seen a single pair of slashes on a line to make the whole rest of the line into a comment. The /* character signifies the beginning of a comment, which can be only even part of a line if you want, or many lines as this one is, and the */ indicates the end of that comment. So if I delete the beginning and the end of the comment, now this code is incorporated into my application again. And I'll compile it. I'm using the keystroke Control-Shift-B to build. You can also just come up here to the solution, right-click, and choose Build Solution. So what we're doing, I mentioned that unsigned character can hold up to 255. So we're going to put 128 in there. That's fine. We're also going to make a character which can hold up to 127 and try to put 128 into it and see what the debugger has to say about that. So let's put a breakpoint here and run to here. Hits the first breakpoint. I'm just going to hit run again to run down to the second one, and we'll step through. So you can see that N1 has the numerical value 128, and this is the character that represents. We don't really care about it as a character, we're using it for numbers. And N2 is showing that it holds the number -128. That's because of the way that numbers are represented in terms of bits, and the bit pattern, when you try to put 128 into something that can't hold it, ends up being interpreted as the largest negative number it can hold. So when we put those onto the output, that's what it's going to print out, and that can be really confusing. If we try even bigger numbers, say 254, which is about as much as N1 can hold, N1 successfully reports back 254. Again, it's a very strange character. But N2 thinks that's -2. And finally, if we take a number that's too large for both of them, like 300, they both say 44. Here's N2 saying 44, and down here you see N1 saying 44. You notice there were no warnings, no exceptions, nothing at runtime to tell us that this was a bad thing. And that really brings me back to what I said before about the compiler as your friend. So let's let this application run back out. And I'm going to compile the application once again. So rebuild the solution. Normally the compiler is pretty smart. It only builds things that have changed. When you choose rebuild, it builds everything whether it needs to or not. And for the first time, I'm going to show you my build output. What we have here in the output is a whole pile of warning messages. They're not errors. The compile succeeds, the application can run, but they are all warnings from the compiler, from your friend, the compiler. And it's saying, look, you're converting, let's double click these to go to the lines. You're converting that double 2.2 and putting it in an integer. Possible loss of data. Yes, indeed. Here, you're forcing integer value into a Boolean value, and among other things, that's a performance warning. And of course, if you actually planned to keep the number around as a number, you've lost it. All you know is true or false at that point. Here, this warning, I'm going to truncate your 128. It won't fit in here. And it goes on to continue to warn you about truncations all the time that I'm messing around with our character number. Now, although you wouldn't really put outsized numbers into characters, you might accidentally put outsized numbers into shorts and longs. And I don't expect anyone to memorize how long these things can hold. I'll show you how to find that out in just a moment. But the important thing to know is that the compiler knows how long they can hold. So that especially when you're working directly with constants, it can tell you this data type cannot hold the number 128. You've chosen the wrong data type if 128 is what you need to put into it. And that's one of the services the compiler can offer to you. As well, if you take two doubles regardless of their values and sort of multiply them together and try to put the answer into an integer, even though they're not constants at compile time like 2.2, the compiler still knows you're probably going to lose data when you take that double and put it into an integer, and it will warn you about it. In many ways, the moral of the story is don't ignore your compiler warning messages. Read them. They are trying to help you. Now, I promised I'd show you how to get the value that a certain type can hold. How big a number can you put in a car? How big a number can you put in an int, and so on. If you go into MSDN and you find this page, Fundamental Types, you can navigate to it based on what you can see here on the screen of this tree, or you could just search for it. Then you'll find the different types in C++, along with some specific extra types that Visual C++ defines. For the best cross-platform experience, you want to stick with the ones that are actual built-in C++ types. So you can see here the definition of car, bool, short, int, and so on, and talking a little bit about how long they are. However, I find that the best thing to figure out their length is to come down here to this chart, and you can see that it takes up a byte of memory, or 2 bytes of memory, or 8 bytes of memory, or so on. And as well, if you scroll right down to the bottom, you'll see this link here to data type ranges. Here, it shows you the range that each type can hold. So int is 4 bytes. It can hold minus 2 billion to positive 2 billion and change. Car, as I mentioned, can hold minus 128 to 127, whereas unsigned car can hold 0 to 255, and so on. So if you want to know what maximum and minimum numbers you can put into a particular data type, this is the place to come and look. As I say, if you're just generally working with small numbers, you might be able to get away with car, but 255 and 127 are not that big, so just go with int, and generally speaking, unless you're writing an operating system, you're going to be fine. And that's my advice to most people. Put integers into ints, put real numbers into doubles, and don't spend too much time worrying about exactly what size and how many bits the various types are until it matters to you. And when you're just getting started, it doesn't matter yet. But you have seen the types that we have in C++ now, and a little bit of what happens as you move the data back and forth from one type